So we are doing attributes of absolute value functions, part 1. This is section 2-3, and there's a part 1 and a part 2 to this section. So attributes of a function are its domain, the range, is there a asymptote, is there a minimum, a maximum? What are the key aspects of that function? So if we go back to when we talked about parent functions for absolute value, so for absolute value, we have when the absolute value of x equals x, that's because we have a line, a positive slope to the right of 0, and then we have a negative slope to the left of 0. And then they come together to make one function, okay? The axis of symmetry is the invisible line that divides the function in half. For the parent function, your axis of symmetry is at x equals 0, okay? Your vertex can either be a maximum or a minimum. It's your highest or your lowest point of your absolute value. Your domain, because the function is going forever to the left and forever to the right, the domain is all real numbers. Your range depends on whether you have a maximum or a minimum, but for our parent function, we have a minimum, so it's y is greater than or equal to 0. And then your x-intercepts and y-intercept are the same because it's currently at the origin. However, as the function shifts and moves, the x and y-intercepts will also. Okay, so these are our key attributes of the parent function. Now, just like you have a parent, you look like your parent, but you don't have every aspect of your parent. And so the same for functions. This is just our parent function. Once this graph is shuffled left, right, up, down, it becomes its own person. Own graph, not person. So graphing absolute value functions, option A. And so the first thing that we can do is, we're still not using the calculator. This is you being the grapher, doing the graphing. 1, create a table of at least 3 values. One value should be your HK, because that tells us the vertex of the function. Choose 2 to 3 x values to the right and left of the vertex. And then we're going to substitute those values in and evaluate to find y. Then plot the points on the graph and connect them. Then we should be able to describe the domain, the range, the axis of symmetry, and intercepts of the graphs. So following those steps, here we have the function f of x equals the absolute value of x plus 2 minus 3. So the first thing we're going to acknowledge is, what is our vertex? So we're going to find our middle ground, our vertex. And your vertex is made up of your h and your k, okay? In the standard function of this, of x plus 2 minus k, I'm going to go back really quick. Notice how h is already negative. What I like to remind you here is that our x is a liar. There are x for a reason, right? And so our x is a liar. So even though it looks like it's a plus 2, it's actually representing a negative 2, because this is x minus negative 2. It just was simplified to be a plus 2, okay? So your vertex is made up of your h, comma, your k value. So the x value of my h is negative 2. The y value of my vertex is going to be negative 3. So that's my vertex. And then I did that. Step 2 says choose 2 to 3 values to the right and left of the vertex. So I'm going to choose 2 to 3 values to the right and left of it. I'm going to go with negative 1 and 0. I'm going to go with negative 3 and negative 4. And I'm going to substitute these values in to solve for y. So substituting them in, I'm looking for f of negative 4, which would be the absolute value of negative 4 plus 2 minus 3. So substituting that in, I have negative 4 plus 2 is negative 2. The absolute value of negative 2 is 2. So that gives me 2 minus 3, and therefore my y value is at negative 1. Negative 3, so f of negative 3, substitute that in. I have negative 3 plus 2 minus 3. That's going to give me negative 1. Absolute value of negative 1 is 1. 1 minus 3 is going to be -2. Now, because absolute values have symmetry, if I have the values to the left, then I also have the values to the right that are the same distance from my vertex. So I'm going to show you, but if I did this correctly, I should end up with -2 and -1 on the right-hand side. So f of -1 equals the absolute value of -1 plus 2 minus 3. -1 plus 2 is going to give me 1, and 1 minus 3 equals -2. Let me fix that. And then f of 0 equals absolute value of 0 plus 2 minus 3, which equals 2 minus 3, which equals -1. So I know that I did it right because these y values are symmetrical to the y value, to my vertex. So I'm going to plot those points. So I go to -2, -3, boom. I'm going to go -4, -1, -3, -2, and I'm going to mimic it on the other side. And I can follow this pattern if I want to keep going to the x-axis. So looking how I got from one point to the next, I can continue. So I rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. Once you recognize the pattern, aka the slope that's taking place, you can make an even more accurate graph. And I'm connecting them. And connecting them. And that would be my graph. So now that I have my graph, I can describe everything that it's asking of me. I should be able to say, what's the domain? What's the range? What's my axis of symmetry? And all that fun stuff. So the domain for this graph is going to be all real numbers, -infinity to +infinity, because it's going forever to the left and forever to the right, correct? The range of this function, remember range is from bottom to top. So my lowest value that I go to is at -3. So at -3, that's my lowest value. So I start at -3 and I go on to infinity. Remember, if I want to write this as a inequality, it will be y is greater than or equal to -3. Okay, next, my axis of symmetry. Your axis of symmetry is always defined by the x value of your vertex. The x value of my vertex is -2, right? This is my axis of symmetry. So my axis of symmetry is at x equals -2. And then identifying my intercepts. So all of my intercepts. So my y-intercept is at, I come over here, it's at 0, -1. My x-intercepts are at 1, 0, and at -5, 0. And now I've analyzed this whole graph. I created the table, I made the graph, and I found the domain, the range, the x-intercept, the y-intercept, and the axis of symmetry. Any questions so far? No questions? Okay. So just going over it again, graphing and state the domain, range, axis of symmetry, and intercept. So now I wanted to do a fraction problem because a lot of times you guys are like, no, it's a fraction. Okay, it's okay. Notice that this problem, I do not have a k, a visible k. I do have k, it's a 0. So if you need to add that for yourself, please go ahead and do that. Step 1 says to identify my h and my k. My h and my k, that's my vertex, that's the middle point that I'm basing everything off of here. So I have 1. So again, this is identifying my vertex, my h and my k. I have 1, 0. Okay, remember my x is a liar, so it is a +1. All right, and then I'm going to choose points to the left and to the right of 1. So to the left, I have 0, -1. To the right, I have 2 and 3. So now I'm going to plug in and evaluate. So if I plug in f of -1, I get 1/3 absolute value of -1 minus 1 absolute value. And that's going to give me 1/3. -1 minus 1 is -2. And the absolute value of -2 is +2. So I'm going to do +2. And that gives me 1/3 times 2 is going to be 2/3. Notice how I left it as a fraction. Fractions are our friends. I'm going to do 0. F of 0 equals 1/3 absolute value of 0 minus 1. That gives me 1/3 times 1, 1/3. Okay, so for that same token, these values should mimic the same thing, right? F of 2, because they're symmetrical, and F of 3 should represent the same thing of 2/3, of 1/3 and 2/3. Okay, so now when you're graphing this, the easiest thing to graph is 1, 0. So if I go to 1, go to 0, boom. Now graphing 0, 1/3, 0, -1, that's going to be tricky. So if I go to 0, my cursor keeps disappearing. I don't know where it's going. Oh, there it is. So if I go to 0 and I'm working with thirds, I can say, okay, well, I'm just going to go ahead and divide you into thirds. I can create that third for myself and say, okay, here's 0, 1/3. I can go, here's -1, 1/3. So notice how I'm creating that for myself. Okay, you can count, you can divide the spaces based on whatever fraction you're working with. And I'm going to mimic it over here. So again, I need it 1/3. And I need it 2/3. And now to the best of my ability, I'm going to connect. I'm just going to draw it there. Okay. And so there's my graph. Fractions are our friends. Okay. So now I can analyze the graph and describe every aspect of it. So analyzing this graph, I need to find the domain. Well, what's the domain of my graph? Well, the domain is going to still be all real numbers, -infinity to +infinity. The range of my graph. Well, my graph starts at 0 and goes to infinity. So my range is 0 to infinity. Okay. My axis of symmetry, remember your axis of symmetry is based off of your x value of your vertex. The x value of my vertex is at 1. So my axis of symmetry is at x equals 1. And then my intercepts. Well, my two intercepts are easy. They're actually conveniently on my graph. So remember, if I'm looking for intercepts, if I'm looking for my y-intercept, I'm looking for when x equals 0. This represents my y-intercept. If I'm looking for my x-intercept, I'm looking for when y equals 0. That represents my x-intercept. Okay, so I now know I have my y-intercept is going to be at 0, 1/3. And my x-intercept is at 1, 0. And ta-da, graph has been analyzed. Okay, did working with a fraction make it any different of a process? No. It made me draw a less accurate graph, however, but the process is still there. Okay, option B for graphing absolute value functions. Okay, so step 1, HK tells us the vertex of the function. So we plot this point first. Okay, A tells us the slope of our lines that create the graph. Okay, we will use the slopes to graph the rest of the function. To graph the right side of the graph, you will use the value of A as your rise over run. To graph the left side of your graph, you will multiply the value of A. Oh, I forgot the word -1. You will multiply the value of A by -1. Forgot that whole sentence. -1, and use that value as your rise over run. Okay, and then state the domain, range, axis of symmetry, intercepts. So doing that, here we have negative absolute value of x minus 2 plus 4. So my vertex, again, is based off my h and my k. So your h comma your k is your vertex. So for this one, my vertex is at 2 comma 4. Easy enough. So I go to 2, go to 4. Vertex done. Okay, the right side line of my graph. So looking at my A, right here, it's negative. And if there's no number there, then my A is a -1. Does that make sense? So currently A equals -1. So that means the right side line, the slope is going to be -1 over 1. That's the slope of the right side. Okay, my left side line, it says I'm going to take A and multiply by negative. So if I take -1 and multiply it by negative, I'm going to end up with a +1. And that's the slope of my left side. So from here, I know I'm going to go down 1 over 1. Down 1 over 1. That's a negative slope being created. On this side, I'm going a negative, and a negative makes a positive. So even though I'm going down 1 and left 1, I'm becoming a positive because down, left, negative, positive. I can do it. Okay, and then I'm going to connect the dots. And bam, graphed. Okay, so from here, I can describe everything that I need to describe: the domain, the range, axis of symmetry, and the intercepts. So my domain for this graph is still going to be -infinity to +infinity. My range, this time, it is a maximum vertex. So it's a maximum vertex, which means that I'm starting at -infinity and I'm working my way up. So I'm starting at -infinity and I'm working my way to 4. Or y is less than or equal to 4. My y-intercept, I can clearly see my y-intercept is at 0, 2. X-intercept, I see one value of my x-intercept. And so for that one value of my x-intercept, I know it's at -2, 0. Using deductive reasoning, where would my next one be? So right here, this is 5. So if I'm continuing the pattern down 1 over 1, it's going to end up at 6, right? So even though it's not on the graph, it still exists. And so you still need to state where it would exist. How do you feel about method B of graphing absolute values? Any objections? Anyone's like, oh, okay. Any questions that need to be clarified? Ask me now, ask me later, let me know. Axis of symmetry, my axis of symmetry is at x equals 2. All right, last one, example D, using option B of graphing. So again, I'm going to identify my vertex. Remember, my x is a liar, so this is actually a -3. And so, but here's my h, here's my k, vertex h comma k. It's at -3, 1. So at -3, 1 is my vertex. Okay. The right side line is based off what my a is currently. Well, a equals 2. So therefore, my slope equals 2 over 1. The left side is the -a. So that would be -a, which make it -2. So my slope equals -2 over 1. So from my vertex, on the right side, I'm going to go up 2, over 1, up 2, over 1. Okay. On my left side, I'm going to go up 2, left 1 to make it negative, up 2, left 1 to make it negative. And I'm going to connect. Okay. All is connected. So now I'm ready to describe all the attributes. The domain, well, the domain here would be from negative infinity to positive infinity. The range, it has a minimum vertex. So my range starts at 1 and goes forever to infinity, or y is greater than or equal to 1. My y-intercept, I cannot see where it's going, but I can either use deductive reasoning or I can find out what f of 0 equals. And so I can substitute in 0 and find f of 0 to find my y-intercept. So when I substitute that in, I have 2 absolute value of 0 plus 3 plus 1. And that's going to give me 0 plus 3 is 3. Absolute value of 3 is 3. 3 times 2 is 6. 6 plus 1 is 7. So my y-intercept is at 0, 7. Just because I don't see it doesn't mean I leave the answer blank, okay? And my x-intercept, there isn't any. This graph does not cross the x-axis, so therefore there are not any x-intercepts, okay? Last, my axis of symmetry. My axis of symmetry is the invisible line that divides it in half, and it is at x equals -3. And now we've analyzed the graph. We've talked about everything that it is. Bam. Ta-da. And that concludes our notes.